Hi guys, this is O-Level Chemistry, paper 11, June 2017, question 11. A compound contains 70% by mass of iron and 30% by mass of oxygen. What is its empirical formula? So we've got iron, we've got oxygen. The first thing we will do is divide the percentage by mass by the AR of the element. So 70 upon 56 and 30 upon 16. This gives us a value of 1.25 in the case of iron and 1.875 in case of oxygen. So now we divide these numbers by the lowest value, which is 1.25, which gives us a value of 1 for iron and a value of 1.46 for oxygen. Now, we multiply these values by 2 to end up with 2 moles of iron and 3 moles of oxygen. Therefore, the empirical formula of the oxide of iron is Fe2O3, which makes option B the correct option for this question. Question 12. The formula for hydrated copper nitrate is given. It contains 36.5% water of crystallization by mass. So the MR of copper nitrate would be 64 plus 28 plus 96. This would be the MR of copper nitrate, which is anhydrous. And this is equal to 188. So 188 is the mass of anhydrous copper nitrate, and the percentage of copper nitrate in the hydrated copper nitrate would be 100 minus 36.5, giving us a value of 63.5%. Therefore, if 63.5% is equal to 188 grams, then 100% of the mass would be equal to how much? This would be 100 divided by 63.5 multiplied by 188, giving us a mass of 296 for hydrated copper nitrate. Now, out of this 296, 188 is the mass of anhydrous copper nitrate. When we subtract this, we end up with 108 as the MR of H2O. So since we have got the MR of H2O as 108, so X into 18 or 18X equals 108, because 18 is the mass of 1 mole of water and the number of moles of water is X. So X would be equal to 108 divided by 18, giving us a value of 6. Therefore, the formula for copper nitrate hydrated is CuNO3 twice dot 6H2O, making option C the correct option for this question. Question 13. Dilute sulfuric acid is electrolyzed between inert electrodes. So this would produce hydrogen at the cathode and oxygen at the anode. Which statements are correct? Hydrogen is released at the negative electrode. Cathode is the negative electrode, so this statement is correct. Oxygen is released at the positive electrode. Anode is the positive electrode, so this statement is correct. Sulfur dioxide is released at the positive electrode. Sulfur dioxide is not produced at all. And the acid becomes more concentrated. Yes, because when water is electrolyzed and hydrogen and oxygen gases are removed, the quantity of water in the solution decreases, thereby increasing the concentration of the acid present. So statements 1, 2, and 4 being correct makes option A the correct option for this question. Question 14. Concentrated aqueous calcium iodide undergoes electrolysis in a similar way to aqueous sodium chloride. Okay. So if aqueous sodium chloride was undergoing electrolysis, we would have hydrogen at the cathode and chlorine at the anode. So for concentrated aqueous calcium iodide, we would have hydrogen at the cathode and iodine at the anode. And anode is the positive terminal. So we have production of iodine. Cathode is the negative terminal. We have production of hydrogen gas. Okay. What would be formed at each electrode? At the positive electrode, we would have iodine, eliminating options C and D. And at the negative electrode, we would have hydrogen, eliminating option A, making option B the correct option for this question. Question 15. Aluminum is obtained by the electrolysis of molten aluminum oxide. Okay, and the diagram is given. Which row shows the electrode at which aluminum is formed and the correct equation for its formation? So the electrode at which aluminum would be formed would be the cathode, because aluminum ions are reduced to aluminum metal, and the equation would be Al3 positive plus 3 electrons gives Al, making option C the correct option for this question. Question 16. The energy profile diagram for the forward direction of a reversible reaction is shown. So it is an endothermic reaction in the forward direction. For the reverse reaction, which row correctly shows the sign of the activation energy and the type of enthalpy change? Type of enthalpy change would be exothermic. That eliminates options A and C. And we need to remember that the activation energy will always be a positive value, because it is the minimum energy required for the reaction to occur. Requirement means a positive sign for the energy value. So in option B, we've got a negative sign for activation energy, which will never be the case. And in D, we have a positive sign for activation energy, which will always be the case. Therefore, option D is the correct option for this question. Question 17. The formation of liquid water from hydrogen and oxygen may occur in three stages. In stage one, we have got gaseous hydrogen and gaseous oxygen forming atomic gaseous hydrogen and atomic gaseous oxygen. So bonds are being broken. Since bonds are being broken, this reaction requires energy, so it is an endothermic reaction. In stage two, the gaseous atoms are forming the gaseous molecule of steam. So since bonds are forming, this is an exothermic reaction. In stage three, we've got steam condensing to liquid. So gas changing state to liquid releases energy. So this is also an exothermic reaction. Which stage would be exothermic? So one is endothermic, stages 2 and 3 are exothermic, making option C the correct option for this question. Question 18. The equation shows the formation of sulfur trioxide in the contact process. What would decrease the yield of sulfur trioxide? Decreasing the yield of sulfur trioxide means the equilibrium will be favored in the backward direction, or the equilibrium will shift towards the left. Okay. Addition of more oxygen. If you increase the concentration of oxygen, which is a reactant, the equilibrium will be favored in the forward direction. An increase in pressure. An increase in pressure favors the side with the lesser number of moles. Since there are 3 moles of reactants and 2 moles of products, the equilibrium will be favored in the forward direction. An increase in temperature. Therefore, an increase in temperature will favor the endothermic side of the reaction, which is the backward reaction, since the forward reaction has the delta H value written with the negative sign, showing that the forward reaction is exothermic. So an increase in temperature favors the endothermic side. The equilibrium will shift backwards. And the last one, removal of sulfur trioxide from the reaction chamber. If the concentration of product decreases, the reaction moves towards the forward side in order to restore the concentration of the product. Therefore, out of the 4 given options, A, B, and D will favor the equilibrium moving forward, while C will favor the equilibrium moving backward, which is the requirement of the question, making option C the correct option for this question. Question 19. Magnesium carbonate reacts with dilute hydrochloric acid to form magnesium chloride, carbon dioxide, and water. The rate of the reaction is found by reacting the magnesium carbonate and dilute hydrochloric acid in a conical flask. The mass of the flask and the contents is measured every 20 seconds. So we are measuring the loss in the mass of the flask, and the mass loss is the CO2 that is evolved. Which graph correctly shows the change in mass of the flask and contents with time? So options A and B are directly eliminated because they are showing an increase in the mass with time. C and D are showing a decrease in the mass with time. C shows that the mass decreases and reaches zero. It is not possible for the flask to have a zero mass because we have dilute hydrochloric acid and magnesium carbonate reacting to form magnesium chloride, carbon dioxide, and water. The only thing that is lost is carbon dioxide. So it would have a mass remaining even after the reaction is complete. So option C is incorrect. Option D shows a decrease in mass, which represents loss of carbon dioxide, and the mass eventually becomes constant after the reaction has been completed. Therefore, option D is the correct option for this question. Question 20. At the start of a reaction, a 1 dm cube solution contains 0.3 moles of ethanol. After 100 seconds, the concentration of ethanol has decreased to 0.296. That means in those 100 seconds, ethanol goes from 0.3 to 0.296. That means the concentration of ethanol that was used up was 0.004 mole per dm cube. And this is the concentration used up in 100 seconds. So what are they asking us? What is the rate of reaction over the first 100 seconds? So rate is given as change in concentration upon time. So the change in concentration is 0.004 mole per dm cube and time is 100 seconds. So this would give us a value of 4 into 10 to the power of minus 5 mole per dm cube per second. So this answer is present in option C, making C the correct option for this question.